you very much, and thanks everybody for coming. And I'm saying this not out of politeness and out of etiquette. I'm really thankful and really excited to see like 80 persons, because my yesterday's talk had only 8, which was a little bit frustrating. So thank you for coming, and I'm happy to see our conference evolving and growing. Maybe we can have 200 next year. Also, hello everybody watching us live. Here's Tarif. I know you're there. So, without further ado, our company offers an integrated software solution covering all the aspects of modern banking in the digital transformation era. We have many customers, we have many offices, and among other components, we are unsurprisingly offering an identity component. As you might guess, it's built on top of Keycloak. And unsurprisingly, I am a member of identity team, Backbase, working as resident Keycloak expert. Also, I'm an independent Keycloak consultant and expert. I'm a member of OAuth SIG, and recently I have contributed to a few internet standards, DPOP being the most notable. Special thanks to our SIG group. They did a great job progressing with FAPI and Verifiable Credentials. But in the OAuth world, in the internet standards world, there's a lot going on outside of those realms of Verifiable Credentials and FAPI. So I have picked 4 coming specifications that I will provide an overview today. So the choice was dictated both by requirements of our company and my observations and experience as an independent expert. So only yesterday I have realized that we did have a dedicated session about first-party applications. It is hidden behind the pre-recorded sessions tab. It is not obvious. And it is a recorded talk by our colleague Martin, who unfortunately didn't make it to Vienna. So I just suggest that you watch it, and I will give a very brief overview and focus on some technical details. So why do we need a new standard for native user experience for authentication? Because we don't have one, and people want one. What does the first partiness mean? That means that both target application and authorization server are owned, developed, managed by the same party. So, and it would be like natural to provide an integrated user experience between them. And currently, the only standard option that we have is just to spawn a browser. And the user experience with the browser might be very different from the native mobile application. So it can be sort of solved for web applications. For example, we have created a Angular-based theme, login theme for Keycloak, which more or less aligns with the rest of our software. But it is virtually impossible to do the same for mobile. Okay, so with the absence of any standard, people started doing really crazy things. So some deploy custom REST endpoints to implement native authentication. So some try to retrofit ROPC, which is probably known in Keycloak. It does support OTP as a second factor, but it's like an undocumented and non-standard. Also, one of the craziest things is scripting hidden iframes or like web views. Even more controversial decision is to use authorization endpoint programmatically with JSON. So a lot of problems. So, and we need a solution for that. Our goal is to reuse the existing OAuth standards as much as possible without introducing like many new concepts. And most importantly, the decision was made to define like an entry point to a protocol and the exit point, and to leave what happens inside, in between, like outside of the context of the stack. So it is up to vendors. Maybe some of the extensions will define like an interaction based on FIDO, for example, passkeys. So the status, it is currently an individual draft. The voting is ongoing. The call for adoption, and the deadline was 2 days ago. It was September 17th. So there is no official announcement yet, but the voting was like overwhelmingly positive, like 99%. So it's all but sorted. So it will become an internet draft very soon, and maybe an RFC in a couple of years. Maybe sooner, maybe later. Okay, so the application introduces a new endpoint called Authorization Challenge Endpoint. Well, mostly it mirrors the existing authorization endpoint, reusing its parameters. And most notably, the first request needs to be a post with a URL encoded. Okay, with later. And finally, it will return an authorization code in a JSON payload. So there was an early idea to try to reuse the authorization endpoint, but it turned out to be a very bad idea. So because authorization endpoint should never be used programmatically. This is stated clearly in the standard. And for example, security BCP, it explicitly prohibits calls for authorization endpoint. And it's meant to be used by the user agent to accept a post request with URL encoded parameters and to return an HTML. So hence the decision to introduce a new endpoint. Here is how the change would look like. The first request is made to a new endpoint called challenge. You see it accepts mostly pointer. No, is there a laser pointer? No. Okay. So as you see, it accepts almost the same parameters that the authorization endpoint would. They are all valid in this context. Some of the parameters will make no sense, for example, response mode or response type, because the response will always be a JSON containing authorization code. So as you probably noticed, it switches to JSON mode immediately after the very first request. But what happens in between? So it's out of the context of the spec, and it's a deliberate decision. So it's yet to be defined by vendors or by developers of authorization service like Keycloak, for example. So we will have to do it. The current status, and from the Keycloak perspective, first of all, the prototype already exists. And I suggest that you watch the presentation by Martin. And I think the code is published as well. So his presentation is mostly focused on the UI part, as far as I remember. What about challenge endpoint? We will need to introduce a new class for them. I doubt we will be able to inherit it from authorization endpoint class directly. So there are like a lot of private data that probably will need to be moved into a base class. Good news is that token endpoint is not affected at all. So the specification only defines how we obtain an authorization code in a new way. And then we just exchange it for tokens as usual. The back and forth, the part like in between the start and end. So I think we will have to define our own language. For example, how do we pass username and password, etc. And the second factor. And we will need to document it. So the next step would probably to provide native equivalents for the flows that we already have, like login, registration, forgot password, etc. And it would be very nice to ensure that the existing code for authenticators, both built-in, Keycloak built-ins, and third-party, like already developed by the companies, that the code could be reused as much as possible. So with like a minimal rewrite. I know it's challenging, yeah. Next, so it's challenging for me as well because we have like six minutes for every specification. There are 4 of them. So without further ado, next one called transaction tokens. It's a completely different problem. It rises from the transition to the zero trust world. It is a pretty standard situation when we have an external authenticated invocation having some sort of credential like OAuth access token. Then this authenticated request hits the API gateway, and the gateway in its turn initiates a chain of invocations or calls between microservices or workloads. in the zero trust world, we need to ensure that the internal calls can occur only as a result of authenticated external calls. In other words, we would completely rule out spurious invocations between the workloads. For example, if there is a rogue or malicious service, we need to ensure that it cannot call its neighbors in an unauthorized manner. The naive approach is to propagate the external token into the internal perimeter. It has many problems. We won't focus on them today. So if you're interested, I suggest that you watch my yesterday's talk at Open Source Summits Europe. Once it gets published on YouTube, it should take a couple of days, I think. And I would appreciate like more attendees, virtual ones. So the naive approach, it doesn't work, believe me. It has so many problems. The new approach is to introduce a new service called transaction token service. That it will be normally deployed somewhere at the boundary. So it will have sort of connectivity with both authorization server, the external one, and the internal workloads. And the idea is that the API gateway would exchange the external token for an internal one that will be well understood by the workloads. So probably you can already suggest the protocol or like the sub-protocol that I'm going to use for that. Of course, it's token exchange. The status of this specification, of the upcoming specification, it has been already adopted by the working group. So yeah, chances are it will become an RFC one day. So it introduces, so there are three main concepts: the transaction token itself, the protocol, how to obtain it, and the use, how we use it with workloads. The token will be only understood by the microservices inside the perimeter. What's important is of one-time use. It can contain some request-specific data that the external token will never contain, for example. It will be understood by all the workloads, ideally. And there could be some really fine-grained authorization, especially with Keycloak. And importantly, it's built on top of existing standards like OAuth, token exchange, and DIRT. Transaction token, also an important moment, it cannot be opaque. The specification requires that it be a signed DIRT, self-contained one. In bold here are the new claims that are added by the specification. So there is a request context describing the request, can contain like IP address or identifier of the workload. There's the purpose claim, somewhat similar to the scope, like if it's a coarse-grained authorization, and the AZD claim that contains fine-grained authorization. So here is how we acquire the transaction token. It's a standard token exchange, but with the addition of a new profile. Like we use a specialized variant of token exchange. And we supply our external token and we request the transaction token, and it is returned as part of standard token response. And finally, this is how to use it. So it was also a deliberate decision to introduce a new header called TXN token and not to use authorization bearer, because the philosophy is a little bit different with those two. And with a new header, you can actually combine those if needed. Actually, there already exists a proof of concept, so created by yours truly, published on GitHub. So, and there is a whole like a Docker Compose appliance consisting of 5 containers. It's a complete demo, so you can use it. Luckily, we do already have an infrastructure for that, so we not only have like custom run types, we can even have custom token exchange providers. This is what I used. There are a couple of problems with our token exchange. Probably you are aware of that. For example, the client ID is required by our implementation of token exchange, but the transaction token spec says nothing about client ID. So it is not required. So it should be relaxed. And yes, of course, we need to one day to promote our token exchange feature stable. Easier said than done. So I was tempted to add a lol sob emoji to that line, promote to stable. So it's like 3 words, but it could take us hopefully not 3 years. Hopefully it happens sooner. Okay, so there will be an interesting and challenging task. So as you remember, the transaction token, it can contain the identity of the workload. Also, easier said than done. So how do we retrieve the workload identifier in a secure, in a guaranteed way? So probably we'll need to acquire it from the underlying workload identity layer. For example, SPIFFE or the upcoming new one called WIMSI. This is like an uncharted territory. I haven't heard about anyone integrating Keycloak with SPIFFE, but in theory that should work out of the box. But that's a theory, something to explore. Finally, the trusted party. We'll get back to that item later, because it's time to move to another specification that is using the token exchange. It's called identity and authorization chaining across domains. So let's imagine we have two domains, each secured by its own authorization server. And one of the services or workloads, so during the invocation, it needs to call like a gateway on a service from the another trust domain. So this workload needs to identify somehow itself to trust domain 2, possibly, preferably reusing the authentication information that it already obtained from authorization server from domain 1. So how do we do that? The upcoming specification suggests that we do that in 2 steps. The first step is to take the existing access token for the full workload, then to go to authorization server 1 and to exchange it for a temporary credential. We call it authorization grant. And this is going to be a JOT as well, like a temporary thing that will be understood only by domain 2. And then at the second step, we can use assertion framework, a special grant type, to exchange this temporary credential for a real token that we understood by trust domain 2. This document has already been adopted by the working group, and we are waiting for it to become an RFC. So there is a complementary draft that describes the format of the intermediary token called IDJAG assertion grant, JOT assertion grant, which is also a draft now. So this is how it looks. So nothing in bold, because the specification doesn't add anything new to token exchange. It just defines the way we use it. So we take our external access token, provide it to the token exchange call, and we have like a JOT, just a neutral JOT in response. Sorry. And the next step, we use yet another grant type, JOT there, to exchange this temporary credential for a real one. So the huge question, why the authors of the spec didn't use token exchange for both legs? And when I asked this, so one of the authors said, so you're probably the 10th or maybe 20th person to ask this question. So the answer was that like philosophical difference, like without like any technical details. So yeah, this was also like a deliberate decision. From the Keycloak perspective, so what do we have? So this specification has, it defines like 2 aspects. So there could be an initiator, domain 1, and it could be a target, domain 2. Yeah? So the initiator, the auth server from the initiator domain needs to implement a token exchange, and the auth server 2 needs to implement a JOT assertion grant. So to implement the source part, we already have token exchange SPI. So we just need to implement this module. And to implement the target part, so there is a work ongoing on work underway on the JOT assertion grants. So currently it's work in progress, but yeah, it's progressing well. Now again, the trusted party of the same item that we had for transaction tokens. What do I mean by by trusted party? So when I started working on transaction tokens, the previous specification, so I needed in the code to define some third party that we should trust, that we should have the public keys for, and that we should be able to verify the tokens issued by that third party. So what I did is I took the existing class identity provider and created it on the fly without persistence. So it's like a transient identity provider created on the fly. So we have this concept already in Keycloak. I suggest that we generalize this concept and introduce maybe a new like base entity called trust party. Because this pattern, currently we're using it only for brokering. But we can imagine that it could be used in so many other aspects. Transaction tokens and identity chaining being just two of them. We are currently working on OpenID Federation. Yeah, we'll need the same for that. We can imagine that one day. So I remember there was a discussion about shared signals framework and security tokens, security event tokens. So one day we might need to consume security event tokens from third party, and we will need to validate them. Finally, one day we might implement logging in using verifiable credentials and wallets. Therefore, we will need to validate credentials issued by a third party. So yeah, this is just a suggestion for like some refactoring in Keycloak. And last but not least, client ID metadata document. Completely different stuff. So forget about everything you had before. Just clear your mind, reset your mind. So this is just a standard call to authorization endpoint, and client ID is some sort of constant. It's an opaque value, both used with static client registration and dynamic one. Now, there is another approach, unofficially called automatic client registration. So with this approach, we provide a URL that points to client metadata document as client ID. And then it is assumed that the authorization server will follow that URL and retrieve the client and register it on the fly. So why this specification? Because it is already implemented in so many places. So OpenID Federation uses it maybe in a slightly different form. Solid IDC uses it already in the OAuth, and as far as I remember, some other technologies. So it's high time to have it standardized. Yes, and this is currently an individual internet draft at the very, very, very early stages. So there is no call for adoption yet, so it's like a work in progress. It just started maybe a couple of months ago, but still, it's good news. From the implementation standpoint, I think that client policies could be a good candidate here. This is what I used when I implemented that for Solid IDC. We already have a pre-authorization hook. It will be invoked at the moment when client ID is already passed, but not yet validated. So it's just a nice place when we can just trigger our code to retrieve the external metadata. But that's not the main problem. I think the most challenging moment here is that we need to cache this client ID document. We would not want to retrieve it per every request. So we need to define some caching policy and caching mechanism. And here is where we have an overlap with trust party, because there we will need to retrieve like a well-known OpenID metadata from them and store the metadata internally, maybe in a version form. Maybe we'll need some query facilities for that. So yeah, I would suggest that we maybe implement some sort of metadata document storage in Keycloak that could store both client metadata and provider metadata. And that's it. And we have 1 minute for questions and answers. Thank you.
So regarding the transaction tokens, like the idea, but
Me
isn't
too.
it a step back and like a DMC, like demilitarized zone, where I step into the way into the zone and then do stuff? Because if I have different resources, then I can only differentiate on the endpoints that you can allow that or not. So I'm not sure if I really get the concept or where this should be used in that case.
Okay. So the use case So I suggest that you watch my yesterday's presentation.
Perfect. Yeah, then I will do that.
Yeah, we can discuss during a break. No more questions. Thank you very much.